Hey y'all, welcome to 5.3. This is Infinite Geometric Series. We talked about geometric series having a constant ratio, constant multiplier that we call R. This infinite means it has an infinite number of terms. So if we jump right in here to example 1, we're looking for the sum from I equals 0 to infinity. So that's a never-ending number of terms. And it is starting with term I equals 0. So for I equals 0, that first term would be 0.3 times 10 to the 0. Well, 10 to the 0 is 1 times 0.3 is just 0.3. So there's our first term. Our second term would be I equals 1, which would be 0.3 times 10 to the power of 1. That's 0.3 times 10, which is 3. Our next term, I equals 2, 0.3 times 10 squared, that's times 100. That's going to be 30. And we're going to keep going a few more terms. I equals 3 would be 0.3 times 10 to the third. And that is 300. And I'm going to squeeze one more in over here. And we're going to do I equaling 4. So that is 0.3 times 10 to the fourth, which is 3,000. Okay, now those are just the individual terms. That summation notation wants us to add these together. So we are adding these terms. So if we add up these first two, 0.3 plus 3, that is 3.3. When we add 30, we get 33.3. When we add 300, we get 333.3. When we add 3,000, we get 3,333.3, and so on. So this would be the sum, doesn't go that way, it goes this way, from I equals 0 to 4 of that series. And we notice as we keep adding terms, the terms keep getting bigger. And that's the key to what we're going to look at today. So the terms keep getting bigger. Terms keep getting larger. So the sum gets larger. It's going to get larger and larger all over again. So there is actually here, this is what we call when the sum diverges. We talked about that word last time. The sum here diverges. And what that means is that it gets the sum, as we keep going through each individual term, the sum gets further and further apart. So there is really no true sum to this sequence. Now, let's look at example 2. Okay, and you're thinking these are the same numbers. They are. Same, all the same numbers are involved, except we have a 1 over 10 now. So we're going to do the same thing. We're going to find a few terms, and we're going to look at what's going on. We're starting with I equals 0. So when I equals 0, it's 0.3 times 1/10 to the 0 power. 1/10 to the 0 power is 1. So this equals 0.3. For I equaling 1, the next term, that's 0.3 times 1/10 to the first power. So that is 0.03. And then we have for I equaling 2, we'll have 0.3 times 1/10 to the second power. That's 0.003. And we're going to keep going. If I is 3, we have 0.3 times 1/10 to the third power, and that's 0.0003. And I'm going to do one more. If I is 4, that's 0.3 times 1/10 to the fourth. So 0.00003. Those are the terms. And again, that summation notation means we need to add these together. So add these first two terms, we get 0.33. Add the next ones, 0.333. Add the next one, 0.3333. Add the next one, 0.33333. And we can see a pattern here. If we keep going, we will end up with 0.3 repeating, which is 1/3. So the sum of this geometric series truly is 1/3. If we could add terms up to infinity, we would see that sum get closer and closer and closer to 1/3. So therefore, that sum is 1/3. Now, here's the differentiation we need to make here. An infinite geometric series can have a finite sum. Finite sum means an actual answer to the sum of all the terms. So, if it converges, meaning the absolute value of its r is less than 1, then the infinite geometric series has a sum. Okay? And the formula for that sum is right here. It's a first over 1 minus r. That's it. That's your whole formula. A first over 1 minus r. Okay? Now, if that value of r, that common ratio, if that absolute value of r is greater than 1, then this series has no sum, and no sum is your answer to the question. Okay, let's look at a couple of examples here to clear this up a little bit. Example A, 2a. Okay, we have our sum of the series from I equals 9 to infinity, 8 over 7 times 0.8 to the power of I minus 1. Remember that r is the value raised to a variable power. So, in example A, r is 0.8, which is less than 1. So, this series has an infinite sum. This series will have an infinite sum. Part B. Sum of the series from I equals 0 to infinity of 1 over 6 times negative 5 to the power of I. So that r is negative 5, and the absolute value of negative 5 is 5, which is greater than 1. So there is no sum to this series. all depends on the R value. Part 2 of the video coming soon. See y'all.